And we're back to this full stack CRUD application from scratch series. Continuing on from our last video, we got some basic database stuff set up. I believe we set up our connection pool and all that kind of fun stuff, and even wrote our query utility that I showed y'all how it will simplify, or rather help us avoid getting stuck dealing with callbacks and callback hell, and setting up our environment variables for our database connection. And then in this video, we're going to continue on just kind of building up from where we left off. I mean, surprise, that's how this playlist is going to work. So I am going to now start working on improving. No, I think we actually need to get a user of some kind, like registered potentially, and we also have to be able to do logins and stuff like that. So we're going to be focusing on auth and getting some of our queries set up, because I can't insert currently. If we recall what our database structure looked like, we had a users table and we had a notes table. And the point of this application is to take just take random notes about DnD stuff. And as of right now, I can't actually insert any kind of test data to the notes table because I don't have a user currently registered. Right? So I cannot insert a note because each note must be written by somebody in the users table with this foreign key relationship we've established. And because I have no users with an ID of any kind, I cannot write a note as of yet. So I have two choices moving forward here, and this is just a preference thing, really. I can write an insert statement here manually with an email, password, first, last name, and stuff like that, so I can generate something. And then I can write a note for it and then begin working on my queries, or I can just go to the lengths of setting up my registration route and setting up my insert statement and then working from there. So we have a couple choices here, right? So let's see. What would I want to do? You know what? Let's just go ahead and get some test data up and running as painlessly as possible. So we'll have to jump between VS Code, our terminal, and our SQL workbench here. Again, whatever GUI you're using, we'll be jumping to it. I need to generate a user data, and maybe then I can insert a note, and then I can go start working on my queries in my server folder, and then actually adding them to my API endpoints and testing them in Postman, and that'll probably be about where I'm going to have to end this video. We'll find out. So what we are rocking and rolling with right now, I need to insert a test user. I always do like test at test.com, like guest at test.com, and password 123 is a registered password. I do that for a lot of my testing data that you should remove before you go to production. Not saying that from experience. Is something it'd be hilarious if I left guest at test.com deploy this and y'all started messing with all my data. But anyway, we need to register some kind of user, and so to do that, we're going to start writing our insert statement. We'll say insert into the users table the following columns. We need to insert an ID because, in our course and maybe in your practice, you always just use auto-incrementing IDs, but I did say we're going to be using UUID strings to do so. I need to enter their email address, their password. We said their first name and their last name, and then created at will be auto-generated by MySQL here. So, the order of these columns does not have to match the order that you created them in. I could just as easily do last name, email, first name, password, ID. The order in this first set of parentheses for your insert statement does not matter. What does matter is whatever order you pick here must match in this set of parentheses here, right? So if you do the singular value, you have a set of parentheses. The order of the values that you're going to be putting in this second set of parentheses must match the order that you chose in the first set. So you can choose whatever order you want in the first set of the parentheses, but the second one doesn't matter. That's just something that I always have to hammer home to my students. And it's just one of those things where it's just good to know to make sure that you don't think it's syntactically important that I wrote them in the same order I created their columns in here. So I'm moving it down to the new line just so it doesn't extend past my recording window here. So that's why I moved the parentheses set down to the new line. Again, new lines don't actually constitute for anything when you're writing your SQL statements. What matters is the correct syntax of SQL keywords and a semicolon designating this is the end of a command. So that's how we can use new lines and things like that to not have ourselves hurt in any way, shape, or form. So, okay, we need to generate an ID and password. So email. I'll do something here. I'll do ID for a temp here. For email, we will do guest at test.com. For a password, I'm going to leave password 123 here is temporary. Again, we're not going to ever insert this with a plain text password of any kind. I'm not going to do that. First name, guest, last name, user will be our first and last names. There we go. So this is my test data that I am going to prepare to insert here so I can eventually start getting some notes and building out my queries in my VS Code editor, or rather in my node code. But we need to generate an ID first. We saw how we can do that fairly simply by going to our, for example, server TS, and again, going down to like a little testing area that I'm going to goof with here. We're going to import UUID v4, JK, we're going to do v4 as UUID v4 from the UUID library I've installed. We're going to console log a simple call to UUID v4 and grab that ID for our insert statement. And it would help if this was actually running here. There we go. Remember, this is it running the previous code, but then TypeScript will compile everything, Webpack will output everything, and this will be our new code base correctly running here, right? And NodeMon will trigger our server to rerun as a quick refresher of how this works. Yeah, so there is our UUID. That'll be this individual's ID right there. Beautiful stuff. And now, like I said, we are never, ever going to insert plain text passwords into our database, even for test data. Don't even get that into a pattern or habit that you fall into ever. And if you ever find yourself at a place that has plain text passwords stored anywhere for user information, I don't know, find HR, raise a stank about it, bring it up in a meeting and say, we have to stop this, because that's not something that you want your company to be known for, of a database breach that leaked people's plain text passwords and emails, because that's like GG Nori territory right there. But okay. So how are we going to generate an actual password here? Just like with UUID, I think, yeah, yesterday I mentioned we're going to be tackling the Blowfish cipher, and in terms of cryptography, we're going to be using this via a library called bcrypt, right? So let me see if I can bring this up, if I can find it. Now, in our full stack development course, I go over bcrypt and hash tables and things like that in a much more detail and depth, but basically it is a password hashing function. It's based on the Blowfish cipher, and it has some other, basically it incorporates a salt into a hash table to output a value that's very, very difficult to reverse engineer, right? So this is what they will look like right here. I don't know what this one is. Password, this actually could work. I could just grab this ABC123XYZ, a random salt. This is what your bcrypt style passwords will look like once they are generated, right? You'll see a algorithm that's being used, the cost, aka the number of salt rounds, the salt itself early on, well, potentially, and then you have your hash, right? So the point is that a hash table will take any length input and it will output it to a fixed length output. Okay, so if it does that, it's called a table, meaning you could theoretically reverse lookup every single outputted fixed length hash back to its original variable length input, right? Because not everyone's going to have a password that has the same length. That's still reverse engineerable. So from there, adding a salt is like adding some random word or phrase or collection of characters or numbers that when you're going through the process of generating the hash, you randomize the salt going in and out of the hash over and over again. That way they can't simply reverse lookup on the hash table to plain text passwords from their hashes. The salt adds this level of randomization and insanity in trying to reverse engineer that. So your hacker would have to know how many salt rounds, what your salt was, what algorithm you use, and potentially have a large collection of your hashes that they can try and then reverse engineer, meaning it's not impossible, but it is highly, 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 highly improbable, because nothing's impossible, right? I think that's a famous Star Trek The Next Generation quote from Jean-Luc Picard, which I think is everything was impossible at one point until it wasn't. So I'll say it's highly improbable. There's just too many elements that they would have to have in order to actually reverse engineer a salt and hash password back to its original plain text value. It'd be highly improbable, and you'll give yourself a really, really strong starting point, right? So we're going to be using this bcrypt cipher. So how do we actually end up using it? Well, thankfully, it is already coded for us into Node. And there's two different versions. There's one called just plain bcrypt, and there's one called node bcrypt, I believe. Now, plain bcrypt, I want to say, is written in C or C++, I think. Yeah, so here's something I will say about bcrypt is that it is notoriously finicky between node versions. So you want to make sure that whatever node version you're on matches the bcrypt version that you have to install or something like that. I should really check out what mine is. Yeah, so this will use npm to install it, but we'll fall back on something called node.gyp because it has to actually build this because, again, I think it's written in C. I wish it would just tell me somewhere around here. I remember looking it up at some point, and don't want to say something super confidently when it is, maybe it's Python. Yeah, C# and C++, right? That way this stuff gets compiled down that way. So that's why it's doing the job. That's why you'll have some installation issues if you're not careful. I know some of my Mac users that run weird node versions have ran into this problem before, but this was something that I dealt with a lot with my students maybe like 2 or 3 years ago when I started teaching at Covalence, when I was like actually a mid-level teacher. Mid-level as in like I'd been there for a year or two, right? And I ran into this issue a lot, but these days I haven't had students reporting regularly to me that they've been having issues with bcrypt. So just be aware of what node version you're on and what version you're supposed to install on the bcrypt side of things. We're just going to go ahead and take a blind stab at it, which is my favorite way to attack problems, and just see what happens. I'm going to stop this server, or I could open a new window if I wanted to. npm I bcrypt, and I can't remember if it comes with its own typings or not. We're going to quickly find out. Like I said, I'll get a big fat warning if it already did. I just realized I typoed it up there, so whoops. Bcryptorino. Yeah, let's see what happens. Cha-cha. Please. Hey, we got everything seemed to install just fine. Didn't have any issues or errors, which is a nice change of pace. Let's get our server back up and running. My cat Percy is right out of frame below the window here. He's laying down against my side monitor right here and is making sure that just the bottom of my notes are going to be clipped. So if I have to scroll down to them or move my window, he's just making sure that I'm slightly inconvenienced at all times. We're going to go ahead and give her a whirl. Import bcrypt and all its lovely stuff from its own library, and let's see what ends up happening here. Bcrypt . Yeah, and because I'm getting this IntelliSense autocomplete, it tells me that it's successfully imported. It has and the types are also associated with this library correctly because I'm getting all this nice auto-generated stuff right here that's telling me what's going on. So yeah, there we go. Now we can actually generate a fake little password to deal with here. We need to generate ourselves a hash. Now, there are two ways of handling bcrypt information. There is an asynchronous way and there is a synchronous way. I mean, in terms of absolute speed, I don't think we're going to see a huge difference here because of how fast this is, but let's just go ahead and just write this synchronously for now so I can console log it, and maybe when we actually get to the point of registering users and encrypting their passwords for storage to insert into our database, we will maybe then write our functions asynchronously to make sure that, again, we don't have any blocking code whatsoever. But for now, it doesn't really matter. So let's generate ourselves a salt. Now, either we can give it a seed of some kind to generate our own salt, or we can let it generate its own random salt for us. So I will say, hey, bcrypt, gen salt sync synchronously, right? And we're going to do the default. I think it defaults to 12, but we're going to defaults to 10, it looks like. Yeah, default 10. We'll go to 12 because we're fancy like that. We'll do that right there. That generates our salt. Let's see what that looks like out of sheer curiosity. I can't remember the last time I actually logged this information myself, but taking a look at it here, there's our salt, right? Algorithm, cost, rounds, right? And then there's our salt value. And then from there, what we can do is generate our hash. So we're going to say const hash equals, hey, bcrypt, hash synchronously our password, which will be password123, and the generated salt that we just got a moment ago, and let's compare that, and let's take a look at our new hash right now. So what we're going to be seeing, this salted and hashed, will be our password123 value, and that's what she looks like right there. So that leads me to think that we can also theoretically, I'm about to sneeze. Why? No, it's like not. I am or not? Can't tell. Come on. Come on, body. Not sneezing. Okay. We left our password as varchar, but I realize now that we could probably switch it to a char, considering I'm going to be using a, hashed value, which means it has the same length over and over again. Little micro optimization we could toss in our database, but for now, I'm going to take this right here, copy it from my terminal, and go to my database and paste it over password 123, because technically, that's still what it is. It is still password 123, simply salted and hashed, and this is what your database information is actually going to look like. And this is why I said we're never going to store plain text passwords. We're not going to entertain the idea at all. But yeah, that gives me a user I now can theoretically register. So yeah, got the green check mark, which means we have successfully registered our first user. And this statement right here is, clearly what our insert statement is going to, what our query is going to look like in our register users endpoint we're going to be writing possibly in this video, right? That's what it's going to look like right here. So yeah, we got that rocking and rolling, folks. I now have that, which means we can also, should I choose to, I'm going to batch these up here. So what I'm actually going to do is, because again, I want to try and keep anything I write on these videos, I want to try and keep in that SQL text file I mentioned to y'all. I'll say maybe test data. There we go. That way, if you want to follow along, if you're clearly following along here, but if you need to follow along at a later time but don't want to skip through the video going wonder where I wrote this stuff, then this will be available in that text file in the repository itself. And we'll say this is the testing selects area down here. So I'll say select star from users, and voila, we now have ourselves a lovely user we can actually do some query stuff on and mess around with. So yeah, we have now successfully selected a user, and we're good to go to start adding notes. So let's go ahead and write a quick insert for notes. Insert into notes. I need to provide an ID. I need to provide a user ID, which I only have one at the moment. I need to provide a body, which is the text, and that's all I have to do. Value. Excuse me. There we go. That's where our ID is going to go. That's where our user ID is going to go, which is this right here. It has to be this. Remember that foreign key relationship? You can't insert a fake user ID, which is something that's really nice about relational databases like SQL or MySQL in this case, is that if you had someone trying to spam attack you or something like that and they didn't have a user ID to insert with, then this insert statement would fail. That means they can't insert a bunch of bogus bunk notes unless they have a valid user ID. So that's kind of like nice to have a layer of data sanitization just added for us by that foreign key relationship, right? So I can't come down here and make up some user ID and pray it works. That's not going to end up working for us in the long run. That can't work because of that foreign key relationship. That's what I mean by it's nice to have some built-in data sanitization at some level, even though you should probably prevent that from a server-side level and things like that. But at least the database level, someone can't insert a bunch of fake user data anymore. So yeah, we have to go generate an ID again from our VS Code and terminal. And we have to generate a body of text, which might just say this is a test note, LOL, or something like that. So let's head back to VS Code and do the same thing. I'll say import. I should have just left it from before. Maybe I can undo it back to there. Out of laziness, we all know that's what it's all about. In my terminal work, if I've written a statement before in my terminal, then I would rather hit my up arrow key 1,000 times than rewrite it in 5 seconds. So same thing right there. I probably could have just as easily written that faster than hitting Control-Z undo to get back to what I'd written before. But you know what? That's life. There is a new unique ID for our newly generated note. So I'm going to go replace the ID portion here. That is the user ID. And if I'm not mistaken, there is, that's not the one I'm looking for. There is a cool Ipsum community online, oddly enough, that generates and helps write some cool things for us. I like finding, I could have just as easily written whatever lorem ipsum I wanted or whatever garbage test note I wanted, but I like having somewhat accurate and real. I like having themed lorem ipsums. It's just something, a little quirk of mine, because I'm not like the other programmers. It's just something stupid I like to do. I like having flavored lorem ipsum because I'm just that kind of guy. There we go. So yeah, we have a Dungeons and Dragons. I think I looked up DnD ipsum, and it was the second link in my Google. It's ipsum-community.github.io/DnDipsum.com. it is a random DnD keywords thrown into a paragraph for us, and that's fantastic test data for our note here. So I'm going to paste that in there, and I might have to fix some formatting. Yeah, right, there we go. So there is our lovely test note. I will now enter this information. We got the successful insert, and let's go take a look at a quick test select. So we'll say select star from notes, and voila, we have a lovely note that we can now hit from an API endpoint and get some information on. That's what I'm talking about. As a matter of fact, let's go ahead and insert one more of these. So I need to trigger a new UUID. I'll just change my code slightly and save the file, which will trigger it to rerun. There's a new UUID to use. Boom. I'll come back and just paste that here momentarily. There we go. It'll be the same user ID, and I need to go generate a new paragraph. So let's go ahead and copy these 2 lines of code. Paste them, take this new UUID, replace that one there. The user ID has to be the same. And let's go grab a new paragraph and copy it and paste it and fix whatever needs to get fixed. Paste. Fix the spacing there, and adds a space in the front for some reason on that copy paste. And voila, now I can insert this second note. I want to insert 2 so we can practice writing our get one and get all API endpoints. So there we go. We now have 2 notes, and let's confirm that if I go back to my select star from notes, I do indeed get 2 notes. There we go. I don't know what that error code was right there. I think I ran some kind of hotkey. I fat-fingered the wrong hotkey. But select star from notes does indeed get us the note's information. What the ID of the note is, if I have to match it for detailed information later, who wrote the note via their user ID, which we can get actual user information via what's called a join statement, and the body of the note itself, which is well, what the note says, like what's written in the note right there. And then we have our created at as well, which is when the note was written. So they're both written on January 1st, the 19th, and at 1 minute apart. Almost 1 minute apart. Look at that. I was really close in milliseconds, wasn't I? That's pretty impressive, if I do say so myself. Oh, no, that's seconds. That's minute, that's seconds, yeah. Pretty cool. Okay, so now that we have that base level of information inside our database, I'm going to copy this file and paste it into my schema.txt. Paste. I think we can do like schema.sql so it makes more sense. Yeah, look at that. There we go. That's what I'm talking about. I was blanking at the end of the last video. I was like, I think I wrote schema.mysql, and I was like, why isn't it giving me the cool syntax highlighting? And then I realized if I write just .sql, then it gives us a syntax highlighting. So there we go. Much better, much better. Okay, so now this is now up to date with my insert statements of test data and selects, so y'all can copy from our repository should you not want to have to write this stuff yourself, or if you already know what you're doing, whatever. Yeah, right on. So let's go ahead and remove that again, even though I say I should leave that because of how often I keep coming back down there. And now that we have that data successfully selecting from our workbench, now we need to recreate this select right here, getting all notes, and putting it into an API endpoint, right? So to do that, we're going to head to our routes file, to API, to our notes file. Voila, we're here. So like I had said in the previous video, you don't want to write a lot of queries directly in your routes. You almost want this layer of abstraction. Now again, if I was in a hella hurry, then I would import that query utility function, say import that sucker in. I just use a auto import trick with VS Code where I begin writing the name of my function. As long as it knows in TypeScript where that file is, it'll go find it for me, and then I can say, hey, query run select star from notes. That gets me all my notes. Right. Then we get whatever results are. Let's send our response, which will be the results instead of the phrase that just says get all notes. And then if there's an error, the way I have it written now, I'll have to throw new error with that error message inside of it, I think. Can I not do that without curly braces? Possibly not. Yeah. Well, that's because I have my... no, I can just do this right here. What am I talking about, folks? What am I talking about, folks? There we go. So if I'm using the .then syntax, I don't have to use try catch, but because I have my try catch already set up, here's what we would rather do instead. You can actually add the async keyword in front of the recres next callback for express routes. Hell yeah, which means we can now do the following. Await that query, and then send the results. Otherwise, if it throws an error with that query, it'll catch it and move it on to our global error handler. And check it out. That's fine. Like in a small scale project, or if you're just learning, I don't really get annoyed to see queries directly inside of the routes. But again, it's nice to kind of abstract your SQL logic away from the routes. Like this is your networking layer. This is where your routes paths are matched. This is where the logic of what they do should go, but this is not where SQL queries should go, because your SQL queries are part of your data layer. So in larger scale projects, you'll see layers like that. You'll have like a networking layer and a data layer and something in between as well, where sometimes they'll even remove these and call them controllers, right? I think that's what they're called. So like sometimes they'll even abstract these functions out into separate files. So your routes will literally just be their paths, and what controllers will run logic on them. That way, that's all they are. And then you'll look into your controllers, and there'll be this function that I've highlighted, the recres next function, that will then have the logic inside of that, but they'll also still have your data layer separated from those. So in larger scale projects, you kind of want to do that crazy scale of separation to make sure that, you know, if you need to mess with a route path and how it's matched, or what order it's matched in, or what middlewares it has applied to it, you would head to the routes file to do that. If you needed to worry about what that route was supposed to do, you would head to the controllers folder and find that. If you're trying to mess with what query a controller would run, you would head to the database folder. So we're gonna kind of split the difference in the middle and have like, I'm not gonna split these out into controllers and routes. I'm gonna leave the route here, and I guess this function action that runs on an endpoint here, but I will separate out the data layer at least one level. So to do that, first off, before we do that rather, let's go test to see, making sure that my server is running, and that in Postman I no longer get this get all notes message, but instead I see an array of objects. An array of objects, which are my 2 notes from my database. How cool is that, folks? So take a look. I mean, this is like a big step when it comes to server-side development, having our database connected and our first query up and running smoothly. Like, I still get this like childlike wonder of like, I can't believe I did that when I write this stuff from scratch here, and y'all should too. It's a really good feeling to know that you know how to do this again from scratch, which I think is awesome. Something to keep in mind down here. Yeah, these are passed back to me. So take a look in my database right here. They are written at 14, which is 2 o'clock Central Standard Time, at 1400 hours, right? Military time. This is running 24-hour time and not 12-hour time. And if we look in my results here, I don't know if I can zoom in on those a lot. Look at that. What do we see instead of a 14? We see a 20. That is because time zones are treated like, the time zones are treated oddly by the MySQL library, and this is something that annoys me about it quite a bit, and we have to actually deal with this. Like, like my local database stores it on its own internal clock, but this node server, we don't know where it's going to be deployed. It might be on the East Coast, might be deployed on the West Coast. It might have instances, some on the East, some on West, with traffic being diverted to them. We can't let them, where the server is running, and whatever logic it has applied to it, dictate how to automatically parse the times. So maybe in the later video, or maybe at the end of this one, I'll show y'all how to circumvent this problem and standardize things, which is simply just, like I said, I have another video that goes over that, which I'll probably just link in the description below, that goes over how we can change our database connection to have it say, stop trying to take time strings and putting them into date objects, or vice versa. Just give me the time at UTC 0, and then we'll let the server or client or wherever decide how to display that correctly. Because not all moments in time are the same thing. Like I said, December 31st, New Year's for me is 14 hours behind December 31st, New Year's for someone in, say, Tokyo, Japan. not all moments in time are the same for everybody, and that's the big thing you have to wrap your mind around when you're dealing with dates in coding, right? Which is a nightmare in all of its own. I tell my students, if you're an expert at objects, arrays, and dates, then you can get a good programming job pretty much anywhere. Maybe we'll do like a whole Mastering the Date series on our YouTube channel. So speaking of which, make sure to like, comment, and subscribe so this video gets popular, or this video playlist gets popular, and people can learn off of me and help me learn from them. There's been plenty of cool things I've learned from the comments about streamlining my own code and things like that, or like fixing a bad habit that I may not have noticed, or like I developed because I've picked it up from my mentor who had a bad habit. Anyway, back in line here. Yeah, we got that going there, and like I said, we're gonna kind of split the difference here, and we're gonna actually move this query out into its own folder and file, so we can, if we have to mess with database or data layer stuff, we head to that directory and we leave this simply for route logic and its action that it fires on this endpoint. So what we're going to do is, like I said, we have our DB index that we never filled out yesterday because I kept my pool and query utility separate from it, because now I'm going to make a queries folder. I don't have to. I could just make a file, call whatever I want, but I like organizing stuff. What can I say? We're going to make a new file in queries. Not index for once. I'm going to call it the notes.ts file. So if I see in my directory db queries notes, this is where I need to head to modify any queries that deal with my endpoints dealing with retrieving, inserting, updating, or deleting, or whatever we have in the future, notes, which I think is pretty cool. So we're going to import that query utility from the pool file. And we're going to make like a collection of functions to help abstract that data layer away from our API endpoint. So what we're going to do is say const all is a function that takes, at the moment, no arguments. We can customize this later by being able to pass like maybe keywords that will generate different queries depending upon that. But for now, we're just going to do a query that says select, I was off home keys there, select star from notes. And then we'll write export default all, like that. And then from there, I will go to my index file now and say import star as notes from query/notes. I believe that's what I need to do right there. I don't think it's star. I think it's just notes, because that, yeah, I'm exporting an object by default, not giving it a name, meaning I can import it under that name, and this represents the object. And just to confirm, it should be notes.all. Yeah, okay. And then from here, we'll simply export default notes. And something you might be wondering, I have an object set of curly braces, but I'm writing only one word in there. This is a ES6 JavaScript shorthand where it says if the property, which is simply a string value in objects to identify a value somewhere in that object, matches the value of the object. In this case, it is a variable called notes that corresponds to that imported statement. If those two things are the same thing, the key and the value are the same variable name, boom, we can shorthand it like that, and that's what we're taking advantage of right there. So this index file is literally going to be its purpose is going to be import each set of queries to export by default out of here so we can import it more cleanly over here. So rather than importing my query from the pool file, I will say from the DB directory, import that object, which I can call it just DB if I wanted to. So import database from that database index file, which now allows me to write the following: db.notes.all, like so, and voila, we've now kind of abstracted one layer away. We now have a data layer and a route controller layer that are now separated. So this will keep the query logic away from our routes themselves and have them very reusable, which will be nice as well. Let's confirm that nothing has changed by running this query again. This I've zoomed in too far on. Send away. Retrieved it just fine. That's what I'm talking about. Cool. All right. That's awesome. That's some big steps so far. Now that we have that rocking and rolling, let's go start working on how do we maybe log in a user, right? Like at the moment, I have a login route that we've tested, but we need to actually, and look at that. Oh, let's change this data since I just made this new insert here. So we're going to change this to guest@test.com, password 123. So there we go. I'm going to save this new collection I've done here, this new tab, to make sure it represents the correct data that I inserted. Guest@test.com is my email login. And let's start working our way towards this one, because we had this other endpoint. We might as well start working on it, right? So rather than registering a user, let's figure out how we can start logging someone in, right? So what is the process of logging in a user? We need to verify their email exists in our database, right? If it doesn't, we throw an early error saying email doesn't exist. We then have to compare the password they're trying to log in with the hashed and salted value in our database. And how are we going to compare that? Because I can't reverse engineer whatever the heck this is back to password 123, and thankfully, to the rescue will come the bcrypt library. It can take this value and compare it to a plain text value, and it will come back with a Boolean value of true or false. Should it actually compare correctly, it's good to know. Okay. So, and when that happens, what do we do from there? So, again, our full stack curriculum goes through all this in much more detail and explanations, but I'm not going to spend an hour talking about benefits of cookies versus local storage and things like that. So here's what we're going to do. I'm going to be taking a simple, streamlined approach. I'm not saying it's the best. I'm not saying it's without its host of problems, but I'm going to be taking a simple and streamlined way of handling persisting a login state to our applications. We're going to be using JSON Web Tokens because you should be very familiar with those moving into modern coding and things like that. You need to be worried about access tokens and refresh tokens when you're learning about OAuth 2.0 practices. We're not going to go quite that far. Maybe later in the series when I feel like I run out of content and I want to keep this going because I'm a crazy person, maybe we will convert everything in the future to that kind of stuff. But for now, we're going to keep it simple. Once this login is authenticated, meaning, the email's in our database, the passwords compare with the value of true, but for that bcrypt tells us, that means they've logged in. So what does that mean to a application standpoint? We should generate a token, a card, like a ID card, like a token, like a in a hotel room, like in a hotel, you would get your hotel room key card that says, hey, you now have access to your room and maybe some facilities in the hotel. That hotel key card will be like our JSON Web Token. It represents that, you went to the front desk, you authenticated your credentials, we have provided you with this key card that is good for, say, 1 week, 30 days, however long your stay is. That's how long the card is good for, and then after those days are over, the card will no longer work on opening your room. That's kind of like what a JSON Web Token represents. Now, where we store it, is it going to be in our wallets, or maybe it's stored at the front desk and we have to retrieve it every time we come in? That's the concept of stateful versus stateless routing, right? So we're going to choose to simply store that JSON Web Token, give it like an expiration date of a month that our users have to log back in every now and again to make sure that their credentials are indeed authenticated, at least on a once per month basis. It's up to you. Like, I know that in like OAuth 2.0, access tokens will sometimes last a month, or access tokens are typically very short-lived, like 15 minutes, but refresh tokens last much longer than that. Like with Google, like you don't have to log in but like once every 2 months or so to make sure your credentials are still valid. It doesn't ask you to log in every 15 minutes. But that's way more advanced for what this series is currently at. So we need to generate that hotel key card. We need to know what that looks like, right? So thankfully, there are libraries that help us with this as well, where we can go and find a JSON Web Token library. I think it's called JSON Web Token, and we can import it as JWT. I was hoping we can find an example of what one looks like. Yes, this is a JSON Web Token. Please take note of this keyword right here that says encoded. For my newbies out there, this is not encrypted. This is not encrypted information, meaning it is not secure or private. So for the love of all that is holy, do not put anything that is sensitive data inside of your encoded token, because anybody can get it and look at what's inside. Encoded simply means that you can take a big swath of data and encode it into a smaller, more compact form that you can then decode back into the long form as you need. There are 3 parts to a JSON Web Token, which is what it looks like right here. You have a header that contains the token type and the algorithm used. You have a footer that contains a signature, like a secret signature, if you will. And then you have your payload, is commonly called this right here. And the payload is going to look like, because it's a JSON Web Token, it is JSON data. And it's nothing more than an object with some information inside of it. Yeah, who the token refers to. Looks like we have a name in this token, and then IAT is issued at, aka when this token was created. Like when they came and checked into the front desk, this is that timestamp that represents that. This is who that checked into the desk, and maybe sub is like, this is the ID of John Doe in our system, so we can find his ID and delete it should we want to kick him out of our hotel. That's what this kind of is going on right here. So yeah, we need to generate one of these with some data inside of it that corresponds to that user's data in our database. So for example, I may include the user's ID in my token payload so that token can be identified as to who it represents. Maybe I can put their email in there, or maybe their first and last name or something like that for display purposes. At the end of the day, it doesn't really matter what you put in the token. But at the end of the day, I am very much want to know that this token belongs to a specific person in my database when I want to validate them in some way or form, aka authorizing. I want to make sure that that person exists in my database. So at the very least, I'm going to include at a bare minimum their user ID, in the token payload, and that's it. Okay, so if you're wondering, well, hey Luke, you just said it's encoded, meaning anybody can look at it, so do not put any kind of sensitive information like, I don't know, their freaking password in it. Then why are we using this if anyone can look at this information? Couldn't they come in here and attempt to guess somebody else's ID by changing values? Well, in this case, yeah, but when we make our tokens, we will be providing a secret signature of a massive collection of characters. I don't care. I don't know what the signature is. That signature will be used to sign the tokens, but cannot be decoded at all. So while someone can always look at our payload of the token, should we get hacked or we have like a man-in-the-middle attack or like a breach, like maybe someone's listening on our server and finding all JWTs that come by it and looking at what's inside of them. What they cannot do is modify the payload, because when they modify the payload, they cannot re-sign or re-encode the token without our secret, which will exist in an environment variable and be hidden on our server somewhere, right? And not pushed to GitHub. So they can look at the data, but as long as they don't have the signature, they cannot modify the data to try and hack us or get more data out of our database by changing ID values and names and things like that to see if they can't find more information or inject us or hack us somehow. So yeah, again, think of it like a royal seal, right? If this is like medieval times, I mean the restaurant or actual physical medieval times, and we are sitting at court together, and I'm explaining to you how this works, which you probably kill me for being a wizard or a witch, right? But this is a computer, and you wouldn't know what a computer is. But instead, what we're going to think of is like, I get a parchment, and if it has a seal on it that I recognize is the seal of the JWT court, and it is unbroken, I can trust that message probably wasn't tampered with. The person that went to the lengths of tampering it was really good by getting an exact copy of the seal. But anyway, however, if I see the seal is not of the court of JWT, and the seal has a crack in it as if it was opened and read by the messenger, then I can't trust it. And that's what we're going to have our code basically do. If that JWT is either expired, or it does not have the correct seal on it, or the seal seems to be tampered with, we will simply reject reading it and trusting it and say, nah, this ain't gonna happen. And that's what we're gonna be doing from the code side here. So like I said, I go into a lot more detail in our full stack curriculum course, but that's just a little quick breakdown for what we're gonna be building towards here, right? All right, now I think we can finally talk about getting back in here and writing some freaking code. I talked about setting up Passport, and I debated on rolling our own auth, which is not terribly hard. But I did mention learning Passport is just another buzzword you can throw on your resume saying, yeah, I know Passport. It does help roll into third-party logins, like doing a Google OAuth style login for your applications much easier. If I wanted only local logins, meaning my own registration and my own email and password storage and checking, then I probably might not roll with Passport because it adds a lot more overhead than it's worth. But if I do intend to add Google logins as well as your own local email password style logins, then I would probably pick up and use Passport, because that overhead ends up being worth that in the long run. But either way, let's go ahead and dive on into another big piece of the puzzle here of handling authentication. We need to have some logic with Passport that sets up our application, right? So I'm going to close these files out because we're going to be doing a lot of work out of one particular area now, which is our middlewares folder. I'll go ahead and make a passport.ts file. Inside of here, we're going to say import passport. What am I doing uppercase for? Passport from passport. Okay. Now, Passport itself is it's a collection of middlewares and logic to help you set up your Express server to have authentication and authorization. It itself has no internal logic of how to handle a login or validating somebody's JSON web token, right? It doesn't have any of that here, so it's very bare bones. So it itself has, well, think of them as like plugins or extras that you can download, install, and connect onto the Passport bare bones like structure. So like it provides the scaffolding, but you still have to go and buy the drywall and install it yourself. I guess if you want to think of it like an analogy here. So ultimately, the way we end up running this here is that what has to happen is we need to initialize it first off as a middleware on our app. So we have a couple of choices. I could just choose to go do it from my server side and say, hey, import Passport and add it as a middleware on our application here. Or if I just simply write passport.initialize and import this passport file path here, I could do that as well. Either way should work. We might pass it in as like a function. So I might say like export function configure passport like that. That way I can import it on my server, perhaps, like in this import list here, import configure passport from the middleware's passport file. And I can always just say configure passport like this and pass in my app as an argument to this particular little thing here, right? The app that Express creates, I can pass it into configure passport. So I can say pass in my app, which should be a Express application. I can't remember the type for this. Hold on. Import type from Express. I think it's capital A application, if I'm not mistaken. Cool. Yeah, looks like it matches up, right? I could have just looked at this, right? Oh, that's Express. What's the difference between Express and application? Is there a capital E Express? There is. So what if I do this instead? Doesn't look like there's any errors. All right, there, our types match up. So yeah, this is actually a cool thing. Like I know old TS heads may not know this is a thing. This was like a hot new business when it came out like what 2-3 years ago at this point. But import keyword type from library simply brings in a type import that has no footprint on production, right? Because types don't exist in JavaScript. They're only a TypeScript thing. So this is one of those optimizations that where you can add to your import statements when you're importing types specifically to tell them to shut up and make sure that they do not have any kind of bite-sized impact on compiling and production because they don't need to, right? They shouldn't. So this is one way is to ensure that doesn't happen, which now that I'm thinking about it, we actually have that problem. Well, we don't have that here. Oh yeah, we do. Like I have no reason to have the full entirety of Express imported here for these things here. So I could choose to, for example, write the following, import type from Express, and now just bring in those types manually, which would be request, response, and the next function, and then ditch this here. Okay. And now find everywhere I did express dot, command or control D, depending on your operating system, delete that, and everything should still be Gucci down here, right? That way we have a stronger and less needlessly imported code around our code base here. Let's make sure our server didn't crash anywhere. It looks like it's fine. I don't see any errors here. Cool. The 6 errors thing here is because of autosave. Pay attention to the bottom always. I think I'll say that in every video. Okay, so now that I've passed my app into configure passport, I can now, just like I said, tell it to, hey, configure yourself with Passport. That way this function will take care of everything. So like I was saying, it itself is the scaffolding. We still have to go buy the drywall and then install it ourselves. So how do I buy the drywall? We are going to do that by installing what's called a strategy. So we're going to import a particular one called Passport Local. What we mean by a local login is that I have my own database with an email and password that I'm checking against. I'm not going to like Google servers and asking them for authentication. I'm running my own authentication. So that one is called local. And that is found under passport-local. How do I know this? I teach this. That's why I know it. But you would go to Passport's documentation and look at its supported plugins or what are they called? Strategies. Yeah, that's what Passport calls them, strategies. So you could go look at their list of strategies and see all the fun strategies they have available for you and which ones are the most popular. So here we go. We're going to get this one up and running. npm run dev. Let's go back to it. Okay. Wunderbar. And yeah, let's go at import and start using this sucker here. So we're going to say import Passport local from the Passport local that we just finished installing. And let's now set this up. I will say, and here's where it gets kind of crazy. These are kind of like middlewares for Passport, right? So that's what a middleware look like installing into our app. To add this to our Passport scaffolding, we write passport dot, any guesses out there? Use. That's how you add middle. It's middlewares all the way down, y'all, like I said. Now, the Passport local strategy is a class-based object, so we're going to need to write the keyword new and write Passport local. That's not enough. .strategy. I know, this is getting gnarly. And we have to instantiate a new instance of the Passport local strategy. Now, we still have an error because it's telling us that we need to have... Yeah, we need to provide a non-optional configuration object, which is one of these right here. And then I will also say we need to provide what code to run upon our login, right? So we need to pass some options to our login and then the logic to run to our login. So what are our options that we have to worry about? By default, if you look at the documentation for Passport Local, by default, it logs people in with a username and a password. We need to tell it that we're not looking for a username, we're looking for an email. And specifically, we have so it by default looks for a rec.body.username, right? We need to tell it instead to look for a rec.body.email. That is because if you recall back from our auth login route, rec.body.email is where that comes from. So we need to tell it to look for that rec.body.email. And we can do that by going to the configuration object and saying, hey, the username field will instead be found as rec.body.email. And because we're not using sessions, we're going to write them as false. Because again, we're going stateless here and we're going just sticking the token in local storage on the front end and calling it a day for our simple, straightforward auth that, again, not perfect, has problems, but it's a good, simple way to start learning how the more complex pieces work. So we're going to write session false because we want to make sure that we're not starting some weird session stuff in the background that we never end up using. Okay. So there are going to be 3 arguments here to this callback function. The rec.body.email, which it will strip down for us and find as an email. The password they're trying to log in with, aka rec.body.password, that will find for us. And we have to provide a function to tell this strategy, hey, I'm done running my code, continue no further. So that's where the done function comes from in Passport strategies. It means, hey, I'm done doing my job because there's an error, or hey, I'm done doing my job because something's missing, or hey, I'm done doing my job because we have authenticated this user and they are Gucci gang. They are good to go, folks. So here's how this is going to work. Like I said, we have to check if their email exists. If not, done bad, those are our pseudocode will be. If yes, compare password. If not comparing, done bad. Otherwise, done good, because everything has checked out to this point, right? And again, there's several steps we can streamline here, which is fine. But first off, we need to check if their email exists. And how do we do that? We need to run a query to find if their email exists. Basically, what we're going to be attempting to do is run the following. Select star from users where email equals whatever email we're looking for. If they're logging in with guests@test.com, it should be that. And that select statement should bring back to us a positive hit that, yes, I have found this person's information. If we log in with a bad value, it should return nothing, which means that their email doesn't exist in our database. And we should tell them, check your email or password. Don't be specific with these error messages. Normally, I would say be very specific with your error messages for development purposes. But in this case, we do not want to tell them, hey, I can't find the email, but the password seems okay. Like, we don't want to have any kind of that logic when it comes to logging in or registering. It should just be a generic authentication problem that says, hey, the email or password are wrong. Check both of those and try again. Or here's the recover password or recover email process, which there are some videos on our Covalence YouTube channel if you want to check that out. My coworker and co-instructor Andrew has some cool videos and stuff like that, like running your own 2FA and things like that. Okay, so that's basically what our query needs to be here, right? So how do we recreate that in our code base? Well, first off, what I'm gonna do for laziness here is head to my DB folder, pop down queries, make a new users file, users.ts. And I'm just gonna copy and paste from the notes file, paste it in, and just modify it. So, we could have a specific function called find email that might run select star from users where email equals, and here's what we're not going to do. I'm going to change this to a template literal from a vanilla string to do backticks. I'm going to provide a particular arg called email. And what I don't want this to do is I do not, for the love of God, do not, people, do this right here. If anyone in the comments tell me why this is bad, if they pause the video and say, don't do this because, like pop quiz, this is ripe for terrible, terrible times. Why? Because this is opening us up to what's called a SQL injection attack. And it's a very common and unfortunately still happens regularly attack that happens on our databases. And there's a relevant XKCD for this. Look up Bobby Tables or get in the comments if you know what Bobby Tables is. It is a classic way of hacking somebody. This is directly interpolating whatever a user might be sending us into our database query. So what if the email they are logging in with is, say, the following? Oh, I'll use mine. Yeah, there we go. That's my last name. Polish. Something akin to, well, that. It completes the end of this particular query, and then it runs something more malicious, like maybe even this. If they guessed our column names, right? They could maliciously add additional query at the end there, and that's what I mean by they are injecting something new for us in their logged in email. If this is what they're logging in with, and I pass it into email, it will simply get placed inside of there vis-a-vis this, and amount to us running an additional statement that could then, this query is injected to our query because we allowed our user direct interpolation to our queries, which is bad news bears week, and that's what happens. This is very, I don't know if this will actually work, but that is basically what a SQL injection attack is. They are injecting their own custom SQL because we did not sanitize our database input. We can either sanitize it or we can leverage what the MySQL library knows how to do. What I mean by that is, let's head back to our DB pool and I'll show you what I mean. Remember when I left this values tidbit off right here? Well, this is where we're going to start utilizing values. Values can be, well, a singular data. It can be an array or an array of arrays or an object. So there's a couple different choices you have for it, right? This values, if we place our user input in place of values, then the MySQL library can confirm that it is safe from SQL injection attacks. That's why I took this extra step, but didn't quite explain what it was for until, well, today. So what we're going to do is leverage that values, right? So let's see if I can get this to work. Rather than interpolating the email in directly, I will instead place the following, a question mark. A question mark is a placeholder for a value we're going to sanitize and check first before running. Then I'm going to provide a secondary argument to the query where email becomes this values right here, which should get formatted and correctly ran from there. So let's go ahead and test if this is going to work. I'm actually curious about this now. So let's go ahead and export find email. No, that's not. I'm not going to bother with that at all. What we're going to do is just run find email. Console log. No, it's a promise. So I have to write in find email guest at test.com. Then log the results. Catch. Log the error. I'm already going an hour. Dang, y'all. Time flies when trying to build a whole application while explaining your thought process, your choices, and stuff along the way. Who would have thought that's the case when doing one of these long form things? But yeah, that's what we're looking to do right here, and that's what we're going to rock. So I'm going to go back to my server and test this out here, right? So I'm not going to write the testing comment. Y'all know what I'm doing. Directory db queries users, import that path. Let's take a look at our logs. And yeah, check it out. It successfully selected our user for us. And there you go. That's what I'm talking about, folks. So the values did indeed and get formatted correctly, which I like to see. And that's what that question mark you'll see a lot in these queries is. It is a placeholder for a value we have to sanitize first. Now again, what if we then have to write find somebody by their username, find somebody by their password? I wouldn't do that, but we could. Find somebody by their first name, find somebody by their last name. I would have to write a different function for all of those, which seems like a lot of repeated code. And if you're wondering, is there a way to cut down that repetition? Well, hell yeah, brother, there is. There is another placeholder you could do for columns. So email is a column, but what if I want it to be a dynamic column value? For columns, you use 2 question marks. And there you go. So now I can pass in a column to find, and not just an email, but whatever value I intend to find. So here is where things change. I now need to provide an array of my values, and the index positions of the array must correspond to the order of your question marks. So my first set of question marks is for the column value, and my second set is for the value, and there we go. So now instead of just find email, we have a singular find function, and I can pass in what column I'm trying to find and the value I'm trying to find within it. So hopefully this now runs successfully. It sure does. It gave us the exact same console log. If I typo the email, we should get nothing. Keep that in mind. Not finding something is not an error unless we go and change our code to do that. It simply returns to us an empty array. We could take advantage of that. Yeah. What if I want to switch it to first_name as the column instead? And remember, our guest's first name was guest. It should be able to find that. Boom, we got ourselves a dynamic find function that we can now use across our code base. So that right there is taken care of. Remove the testing line from our server, and let's head back over to Passport where we're trying to do this whole freaking mess in the first place, right? Okay, so we can say, let's make this async because I don't want to have to worry about running large swaths of code or crazy daisy chains of .thens. And we'll say done. Now done takes one argument if there's an error, which is the error message itself, and we'll handle it, right? If there is no error, done syntax is done blank or null, comma, and some user information we intend to daisy chain to our middlewares from there. Given the length of this video, we may start checking their email at this. I can finish this out. I can finish this out. Okay, so there's our try catch. So first things first, check if their email exists. That's what we got to do. So what we're going to do is the following. Yeah, okay. User found, await, and let's bring in our DB object. I'm going to use the auto import feature. There we go. I like having them organized this way. I don't know why. I can't help it. DB dot, and I realized, sorry about this, folks. Head to your DB index file because we have not yet done the following. Queries users and users. We never daisy chained out our find query. So db.users.find email, and whatever email they're trying to log in with that comes from this function argument, okay? And what we can do is, I mean, we could combine this into a single step, but I can always just say if. Now, here's something important from our previous console logs. Sorry. Autosave. I should turn autosave off of these videos because it's becoming more of a headache than it's worth. So remember what I mentioned that was important about our queries. Whether it finds one thing, many things, or no things, it is always an array of values. So we have a choice. User found, this variable represents an array of possible values. So if I do array.length, I could check it that way, or I could do an ES6 destructure. Now, it's not going to know because at the moment we have never told it what type is returned from this promise. We have no logic saying what type this query will return, right? Now, if this ES6 destructure works, it will become undefined if it's empty, right? Or it will be a singular object, which is considered truthy in value. So now, if it's not undefined, that means it did not find a user, which means go away. Which means we don't pass an error, we simply pass false as the user value, and then this will terminate the login process because the email was not successfully found. That's one way we could handle this whole problem here. Now again, TypeScript typings are no longer happy with us. This will vary if you're in MySQL too, but in MySQL, what we can do is we can head to our query utility function. We can say that we can optionally pass in what our type return should be, or we can just say default to an any for now until he specifies otherwise. And we simply have to provide that here in the promise to say that's what it's going to resolve with at the time and place we tell it to. So this is not my favorite solution in terms of TypeScript accuracy, but remember what I talked about early in the series, TypeScript is a spectrum. On a big team, I would not do something like this because this is really half-assing it and being really just basically JavaScript with extra steps. But in terms of learning, I think it's pretty good to do that. But check it out. Now that I passed in any, it no longer says promise unknown. It says it can be anything. And as I feel my way through the code and realize what my return types are, I can change it. But for now, changing it to an any gets rid of that error and allows me to then try and run my logic, right? Next, we have to compare their passwords, right? Which thankfully bcrypt can do for us fairly simply. So let's go ahead and import bcrypt from bcrypt. And we can now say if their user found .password from the database does not match their decoded password, we're good to go. But this is not how we're going to do it. We need to use bcrypt to do so. Now, like I said, there is sync and async ways to do this because we're already in an async function. Let us await the result of bcrypt dot, and there is compare, which is asynchronous, not compare sync, that can compare what they are trying to log in with via the login form represented by rec.body.password, password123, and we need to compare it to what's inside the database, which will be the user found object's password field. That is the salted and hashed value in the database that this query found for us. This is the password from rec.body.password they are logging in with. This is what they typed. This is what's stored. This will return a Boolean value of true or false should it, well, not match up or does indeed match up. So that way, if this is not true, it's the same thing. All right, where do I write the not true part? I guess it's there. Yeah, okay. If that's not true, then same thing, done null false. And notice what we're not doing here. We are not giving any kind of specific error message of what's going wrong. We're not saying, hey, the email was right, but the password was wrong. We're not saying the password was right, but the email was wrong. We're going to send a generic message that says, hey, either your email or password is wrong. Check them both and try logging in again. So this is where you don't want to be specific on your errors, right? So if we have passed those two particular things, we can call done null user like that, or user found. And something to keep in mind, we have done what in this find query, folks? select star from users. We used users found password to do that. I want to make sure that this password, even though it's encrypted with a very good and solid cipher, the bcrypt cipher, or blowfish cipher, we do not want this password to continue any further than this spot. So before I even call done null user found, I'm going to delete the user found password property off this object before I go any step further, right? Once I'm done messing with password stuff on an object of data, I'm going to delete that crap to make sure it doesn't get any further than this particular point of code right here, to make sure that it doesn't get passed to a route, which means it doesn't accidentally get passed via an API endpoint response, and all of a sudden people are pulling emails and passwords from our database because we simply forgot to delete something at a certain step somewhere. Very important that you keep that in mind. If you're working with user passwords in code, delete that crap when you're done. Now for TypeScript types, I am getting annoyed that I'm not getting any support here, so here's something we can do. In ORMs, you typically create something that are called models, right? You provide what the model is, aka what your table looks like in MySQL, and it will generate the statements and queries for you and all that kind of fun stuff. We don't have an ORM here, so we're going to do a kind of like a scuffed ORM, if you will, where I might write export, or we might just make an interface here that says users table. My users table has an ID that's a string. It has a email that's a string. It has a password field that's a string. It has a created at, which will be a string at some point in time, right? Not a date. It has a first name string value, and it has a last name string value like that. So what's important to keep in mind here is that our select statements aren't always going to be select everything from. So how is TypeScript going to know what fields we selected and which ones we hadn't? Because as of right now, it's going to think we're always selecting everything. So I'm going to make the choice here to actually make all these properties optional, because my select statement may vary. I might do select first name, comma, last name, and it will not be all of these fields. So that's why I want to make them all optional as a personal choice here. That way I'm not getting TypeScript errors when I'm trying to run custom select statements. So what I can do now is pass a type to the query function that will be replaced in the t equals any. The t will now become this type, which is users table array. Because remember, select statements are always array of these things, no matter what. So now if I go take a look at my passport file, look what changed. User found. It knows that's a users table object. It knows that, well, if it's undefined, that'll be bad. And now we know that user found has indeed a password, which is optional, which is a string. And that's why this delete statement now is safe and TypeScript happy. And there you go. That's how you can do that. Cool. So that is the logic that we ran on that particular file right there. I'm going to get rid of my pseudocode because we're done with that. And there you go. That is what a local configured passport strategy might look like. If you're wondering how we're going to test this, I still have to write a middleware for this and talk about that and add it to our endpoint and stuff like that. And I'm getting tired of talking, so I'm going to take a break. And we'll handle that in the next video, where we actually figure out how to incorporate passports middlewares on our endpoints and begin testing in Postman finally. So I'll see you all in the next video. A lot of coding, great stuff, and yeah, hope you enjoyed the series so far.